What's going on, guys? Mr. Allen here, and we got an interesting little question here with this one. It's not asking us to solve. It says, without solving, how many real or complex solutions would this quadratic equation have? So how do we figure that out? Well, it starts the same. We want to set this bad boy equal to 0. So I'm going to do that. I'm going to add 9 to both sides. I'm going to have 4x squared plus x plus 9 equals 0. Now, the way that we determine the number of solutions and whether they're real or complex is use what's called the discriminant. 99% sure I spelled that correctly. And that is b squared minus 4ac. Where have we seen that before? That's the part that's inside the square root under the radical of our quadratic formula. Now, if b squared minus 4ac is greater than 0, meaning if it's positive, we get 2 real solutions. Now, if b squared minus 4ac is equal to 0, we get 1 real solution. And then if it is less than 0, meaning if it's negative, then we're going to get 2 complex or imaginary solutions. Okay? So let's figure that out. Now, if I plug this all into my wonderful discriminant, I'm going to end up with, let's see here, b squared, so 1 squared, minus 4 times my a value times my c value. Now, if you're looking at this, you're like, you can probably already tell. Maybe not, we'll work it out. We got 1 minus, let's see here, 4 times 4, that's 16, times 9, that's 144. And then, let's see, that's minus 144, right? Because they're all positive except for the 1 negative. So that gives me negative 143. That is most certainly less than 0, so we're dealing with the 2 complex solutions. That's it. That's all we're asked for. We're just asked for what type and how many there will be, right? And we can tell that it's going to be that because if I square root a negative number, I'm going to get an imaginary number, right? Complex number. And in quadratic formula, we had like that plus or minus, so I'm going to add that complex number. I'm going to subtract that complex number, giving me 2 unique complex solutions. That's it. That's dope.